Writing ratios.
A ratio is a comparison of two numbers. Ratios can be written three different ways: A to B, A to B, and A to B. Each of them is read out loud as the ratio of A to B. Each ratio should be reduced to simplest terms.
There are 48 animals in a field. 20 are cows and the rest are horses. Write the ratio for each of these in the form A to B, where A is the number of cows to the number of horses, and B is the number of horses to the number of animals in the field. And remember to reduce your ratios to simplest form.
Alright, for A, the number of cows to the number of horses, we're going to divide both numbers by the greatest common factor, which is 4. So cows, there's 20 cows, so 20, to the number of horses. So how many are left? Well, 48 minus 20 is 28, so there must be 28 horses. So the ratio is 20 to 28, but if we divide both sides by 4, we get a ratio of 5 to 7.
The number of horses to the number of animals in the field. Alright, well, we already figured out that there were 28 horses because there were 48 animals in the field and 20 of them are cows. Therefore, 28 animals left, they're all horses. So therefore, 28 of the 48 animals. It's a ratio of 28 to 48. Can this be reduced? Yes, it can. We can divide the top and bottom by 4. If we do that, 28 divided by 4 is 7, 48 divided by 4 is 12. And that is, in simplest terms, the ratio of horses to animals is 7 to 12. Equivalent ratios, like equivalent fractions, are different ways of writing ratios that have the same value. 3 to 2 is equivalent to 6 to 4. The ratio of 1 to 3 is equivalent to the ratio of 9 to 27. 5/6 is equivalent to 35/42. Equivalent fractions are obtained by multiplying or dividing the numerator and denominator of a fraction by the same number, other than 0. Similarly, equivalent ratios are obtained by multiplying or dividing both sides of the ratio by any number other than 0. In other words, two ratios are considered equivalent if one ratio can be expressed as a multiple of the other. Therefore, a ratio can be written an infinite number of ways, just as fractions can. Two ratios can be seen to be equivalent if they become the same when reduced to simplest terms. This is done by dividing both sides of each common factor until there are no more common factors. Reduce each of these to lowest terms and determine which are equivalent. Alright, 6 to 12. Both of these are divisible by 6. So let's divide both sides by 6, and we get 1 to 2. 9 to 18. Both of these are evenly divisible by 9, so I'm going to go ahead and just divide both sides by 9. We get 1 to 2 again. Look, these are equivalent ratios. As you can see here, you could have also divided both sides by 3 and then by 3 again. So you don't have to find like the biggest multiple immediately. You can start with small numbers and keep going. All right, 4 to 16. Let's try this kind of method. Let's divide both sides by 2. Okay, so then we get 2 is to 8. But look, we can divide by 2 again. And we get 1 to 4. So this one is not an equivalent ratio to the first two. 5 and 10 are both evenly divisible by 5. So I'm going to go ahead and divide both sides by 5. I get 1 to 2. And as you can see, we have 3 equivalent ratios here. This ratio, 5 to 10, 9 to 18, and 6 to 12, all represent 50%, 1 to 2. The equivalent ratios are here circled in green. There are multiple ways to determine if ratios are equivalent. The first way is reducing the ratio to its simplest form. So here, both of these are divisible by 3. So 6 divided by 3 is 2, 15 divided by 3 is 5, so we have 2 to 5. Here, We divide both sides by 5, and we also get 2 to 5. So the ratio of 6 to 15 is equivalent to the ratio of 10 to 25. Since the lowest terms of one ratio are equivalent to the lowest terms of the other, the ratios are equivalent. Another way is finding the common factor. Since the numerator and denominator were multiplied by the same value, these ratios are equivalent. So you can see 4/5 to 12/15. Well, if you multiply the numerator, 4 by 3, you get 12. If you multiply 5 by 3, you get 15. So yeah, these are equivalent ratios. Cross multiplication is the result of multiplying the numerator of one ratio with the denominator of another. Using this technique, we would set 4/5 equal to 12/15. We're going to multiply 4 by 15, and we're going to set that equal to 5 times 12. In our example, since the cross products are equal, right, 4 times 15 is 60, and 5 times 12 is also 60. That means the ratios are equivalent. All the methods described above are based on the definition that two ratios are equivalent if one is a multiple of the other.